Why cloud computing? Before we understand why cloud computing and importance of cloud computing, it's really important to understand how things were working before the cloud computing world. So let's take a very simple topology here, a simple diagram where a user is actually accessing an application over the internet. And remember, this is an era when the cloud computing was not discovered, right? So there is a user who is actually accessing the internet through the application through the internet, and an application can be anything. For in this case, let's assume the application is Amazon, this AWS or Amazon.com, right? It's retail Amazon. So people are actually logging into Amazon and trying to buy stuff, downloading and researching about the product and buying the product. Now, with one user or few users accessing the application, it all looks fine, it all looks working. But now let's see, when since it is actually retail, whenever there is a holiday season like Christmas, New Year, people tend to buy a lot of stuff at that point in time. So that means the same application which is actually running will have to take more load, because there are now millions of users across the world accessing this application to buy stuff. So the transaction amount increases, the resources required for the application increases. So now what a typical application administrator will do in the era of not having a cloud computing, what they would do is they will have to allocate the resource, right? So when you see the application here and we zoom out how the application will be installed, is there will be a server, and server will be having the resources like RAM, CPU, database. There are other things also, but for let's put it simple as of now. You are having an operating system, and there is underlying hardware which consists of resources like RAM, CPU, and database. And on top of that, you are having this application which is actually running on top of this operating system. Now, what the administrator will have to do is he has to do a anticipation of what all are the resources that will be consumed when there is a huge amount of users that's actually going to transact. And that will not be a correct estimate, it will be always a ballpark, because nobody will be able to clearly estimate on that one. But again, it is like understanding maybe X amount, let's say 2 millions of a transaction is going to happen, and then understand the resources that is required for that 2 million transaction, and then buy a bigger hardware to host this particular application. So we call it as a resource planning or capacity planning. Now, there are few problems with that approach. The first problem is the cost. So the customer has to pay the amount for this high-end box just because of the high traffic season. Remember, once that season, maybe the Christmas or the New Year season is over, we are going to have less number of resources. That means we are going to have very less number of transactions. So when there is very less number of transactions, the RAM and the CPU and the storage that is actually used to build this particular hardware is underutilized. So but even it is underutilized for the whole year apart from that season, the administrator has to buy that particular configuration for the server, because we have to serve when people comes in million. So one thing is the cost. So let's call that as a cost issue. Second is the scaling issue. As we have seen, we need a high-end system with lots of memory, CPU, and storage to address high traffic, and companies or the network application architects do the capacity planning. But what if for some reason the traffic is higher than the anticipated traffic at the time of capacity planning? Because we cannot really make sure that this is the amount of traffic that's going to come. We can actually estimate only. Let's say Amazon did a good campaign, and instead of 2 million, there were like 4 million transactions that actually happened in the holiday season. Then what happens is the company has to procure new hardware again to address these needs, because now this amount of hardware, like multiple gigs of RAM and CPU is not enough, because it was anticipated only 2 million, but 4 million came. Now to address that for extra 2 million, you have to buy more hardware. And again, along with that comes the time issue as well. So let's call this as the scaling issue. The next issue is the flexibility issue. Again, depending on the need, we are not able to adjust the resource and expenses, which means if the traffic is low, I should be able to use less resources, and if traffic is more, I should be able to use more resources, which is not possible with this particular model. Because to increase or decrease a resource, we need to make the hardware changes, which is time consuming, which is error prone, and there are a lot of complications in that. So in technical term, which we call this as flexibility issues, right? And finally is the security. Not finally, there is one more item we are going to discuss, but security is the next issue. So remember, the servers are physically accessed by humans in the data center. When there is a change that needs to be done on the hardware, those are accessed physically, which means somebody can actually go and access this data. Also in this model, there is no specific granular restrictions on from where the server and its contents are being accessed, right? So it's only in one physical location, and we allow the access from any particular location. We cannot control that access. All the data in the server has almost same access restrictions as well, any of the resources. So this is in a very simple words, that's the security concerns that we are having. And finally is a visibility. As we already saw, as part of the security, almost all data residing in the server has the same access restriction. You cannot say some part of the database has some restriction when it comes from a specific country versus other countries. So we are having same access restrictions. Who accessed it, which part of the entire data was accessed, at what time these details are not provided with this model, right? So let's call this as a visibility issue. We don't have a clear visibility of what our resources are being used, what our resources are being accessed. We don't have a granular control of those resources. So to sum up, there are at high level 5 main issues with this model. The first issue is cost issue. Second issue is the scaling issue. Cost issue, if just to recap what cost issue is, you have to buy a high-end server just for that particular season where there is a higher number of traffic. Second is a scaling issue, and the scaling issue, we have seen that even if we anticipate and bought a high-end server, for some reason, if there is a more traffic coming in, we will not be able to handle that. So that's the scaling issue, which is the second issue. Third issue is a flexibility issue. So we don't have the flexibility to use only the needed resources as and when the traffic comes. And the fourth one is a security issue, because you are actually having a direct access to the hardware, and it's only one hard disk which is in a physical center, and there is no access restriction that can be granularly controlled. And finally, the visibility. We don't have a clear identity of who accesses what, when, and which resources, etc. So these are the problems that we are actually facing with this particular model. Again, there are many more problems and benefits of the cloud, but let's stick to this particular problem as of now. So when companies were running their business with these kind of issues, there already exists a technology which did not have its real usage for a very long time. That technology is virtualization. What virtualization does is it allows a multiple operating system to run in the same hardware by providing the virtual instance of our limited resources. In this case, the limited resources are CPU, memory, and storage. Let's stick to that. There are network and other stuff also, but let's stick to these 3 things as of now. So the application can be installed and on these virtualized OS. That was a great shift and save a few of the issues to an extent. The architecture from this actually kind of changed to this. So what happened was there is an hypervisor, and hypervisor can simulate that. Hypervisor can actually help you to spawn multiple OS and then use a virtualized instance of these resources. So this this was a great shift, and as I told, saved a few of the issues to some extent. Now I can have multiple application, maybe the same application that can do load balance, multiple requests, but remember, still there is a limit on the total CPU, RAM, and storage, because you can virtualize as much of this physical resources are. So the problem, the problem in the above listed still is not completely solved. It is solved to an extent. Then how about if I can have a pool of these resources, a pool of RAM, a pool of CPU, a pool of storage, and then run some automation to help create a virtual resource and deploy the application as and when needed. Is it possible? If that is possible, then companies can actually rent out the services to store the data, rent out the services to access or host the data. It is possible, and that actually gave birth to something called the cloud computing, the cloud world. Now, what we can actually do with this is, with this virtualization is, what actually we can do with this virtualization is, if you look back at the 5 problems, first is the cost. With few clicks or by running a program, we can increase or reduce the resources as needed. The new approach or model can be used now to adjust to build the customer based on the resources that has been consumed. You don't need to buy the high-end box just for the holiday season. What happens is, when the holiday season comes, with some automation or with few clicks, you will be able to add the resources, because again, these are virtualized resources, and there are enough of pool of this RAM and CPU, and then you can actually do a automation, or few clicks you can actually add these resources. You don't need to purchase the hardware. Scaling issue, again, whenever more resources are needed, you can add it instantaneously, as we have just told. We call this as auto scaling. Flexibility issue, resources are added and removed as and when needed. You don't need to add all the resources anticipating there is a huge traffic going to come at the end of this year. Finally, the security, the components needed for the application to work, like DB, front-end infrastructure, etc., can be hosted on different hosts, different OS operating system, as you can actually see here, which actually provides a granular control on which all resources can be accessed from which all places, even between the application, whether some amount of security needs to be there, then that will be possible with that. And visibility, since with the granular access control comes a deeper visibility, who accessed, what time each of the application was accessed, and stuff like that. Sometimes it may not be user accessing the application, it may be, as I told, application, between the application, something is getting accessed, and this gives a deeper visibility. So now with the advent of cloud computing, you can see that the cost is solved, the scaling issue is solved, flexibility issue is solved, security and visibility is also solved. So this is a world of cloud, and that's how it actually benefited. That is the benefit of cloud computing in very simple words. Hope you guys understand it, and let me know the comments if you have anything. This is my attempt to share the knowledge with what I have. Thank you.